Hey everyone! I found these great worksheets titled Stretches inside MathCounts handbooks. Each stretch is on a unique topic, and I'll cover one topic per video. I'll highlight the key concepts of the topic and solve some problems in the stretch. I'll leave a link to the stretch in the description below with an answer key for you guys to work through after you watch the video. Today's stretch will be systems of equations. So when people solve systems of equations, they use two main methods, elimination and substitution. However, this doesn't work well for nonlinear equations, but some nonlinear equations are simply linear equations disguised. We can get rid of these nonlinear elements through clever variable creation and substitution. Let's take a look at question number 2 over here. In question number 2, we have the two equations 2 over x plus 3 over y is 11, and 3 over x minus 1 over y is 11. This looks like it's not going to be a very nice equation because of x and y being in the denominator. However, if we create new variables a and b such that a is equal to 1 over x and b is equal to 1 over y, we get rid of x and y in the denominator. Instead, create a linear equation system of equations in a and b, which are really easy to solve. And question number 3 right here can be solved pretty easily in the same way. So I want you guys to try it out after watching the video. So not only can we make some clever variables, we can also think about these systems graphically. A linear equation is really just a line on a graph. And when two lines intersect in a system of equations, it creates solutions, which are these points where they intersect. So if we have no solutions, such as here in problems 4 and 5, that means that they don't intersect, and that only can happen when the two lines are parallel or their slopes are the same. Also, a side note is that if there are infinitely many solutions, that means that the two equations must be the same line. So why don't we try and solve question number 4? In problems 4 and 5, for what value of k does the linear system have no solutions? Express any non-integer value as a common fraction. So let's start by looking at number 4. In number 4, we have the equations kx plus 3y is 11, and 3x minus y is also 11. So as we were saying with the graph before, we should look for the same slope. So let's turn this into slope-intercept form. So kx plus 3y is equal to 11, and this can be written as y is equal to negative k third x plus 11 thirds. This means that the slope of this equation, m1, is equal to negative k third. The next equation, 3x minus y is equal to 11, can be written as y is equal to 3x minus 11. M2 will be equal to 3. The slopes, we set the slopes equal, so negative k third will be equal to 3. We solve this and we get k is equal to negative 9, which is our answer. Go ahead and try problem 5. It will be done in a pretty similar way. So apart from that, we also sometimes should look at the equations all together. And this will lead to a clever manipulation that can solve what the problem needs, instead of calculating each variable and then getting what the problem needs. So we can do this in problem 6 over here. Given that 2a plus b is 19, 2c plus d is 37, and b plus d is 24, what is the value of a plus b plus c plus d? If you look carefully, you'll notice that if the total number of a's in the equation, all three equations, are 2, and the total number of b's in the equation are 2, there's 2 c's and there are 2 d's as well. So that means that if we add up all the equations, we get 2 times a plus b plus c plus d, and that's 2 times what we need. So we can quickly solve the problem this way. Before I sign off, I have one more problem to share with you. Number 10. A shipping clerk wishes to determine the weights of each of 5 boxes. Each box weighs a different integer amount less than 100 kilograms. Unfortunately, the only scales available measure weights in excess of 100 kilograms. And the clerk therefore decides to weigh the boxes in pairs so that each box is weighed with every other box. The weights is for the 10 pairs of boxes are in kilograms: 110, 112, 113, 114, 115, 116, 117, 118, 120, and 121. From this information, the clerk can determine the weight of each box. What are the weights of each of the 5 boxes? So let's start by creating 5 different variables, one each for a different box. Let's create A, B, C, D, and E. Now let's write down the 10 equations we have. A plus B is 110. That's equation number 1. A plus C is equal to 112. That's equation number 2. A plus D is equal to 113. That's equation number 3. And A plus E is equal to 114. That's equation number 4. We could write them all out, but to save us some time, I'm just going to go to the last 2 equations, which are just C plus E is equal to 120. And that's equation 9. And D plus E is equal to 121, the 10th equation. Now, if we look at these equations and think about them, we might notice something as we did in problem 6. The number of each variable is the same after we add them all up. So let's do just that. 4A plus 4B plus 4C plus 4D plus 4E is equal to 1156. So now we can divide everything by 4 to get A plus B plus C plus D plus E is equal to 289. This is pretty useful because we can quickly find one variable, and once we find one variable, we'll find the rest. So we can take 2 different equations, say let's take equation 1 over here and equation 10 over here, and find their sum. This means that A plus B plus D plus E is equal to 231. That's just the only difference between this equation up here and the equation we just wrote is the missing C term. So let's subtract them and solve for that C. So we get C is equal to 58. Now that we know C is equal to 58, we can calculate A from equation 2, and we get that A is 54. And then we use equations 1, 3, and 4 to find that B is equal to 56, D is equal to 59, and E is equal to 62. This means that the box's weights are these. And this is the stretch on systems of equations. That's all I have for today. Don't forget to leave a like and subscribe to my channel for more math videos. Let me know in the comments what topics would you like to see in the future video. Bye. Thanks for watching.